Okay, today for algebra, we're going to do 3.6 money, and this is day one. We're breaking it into 2 days because there's a lot here, kind of like that percent equation thing. So our objectives are to find cost, markup, markup rate, discount, the discount rate, the retail price, and the sale price. Okay, as well as to find the tip, commission, a commission rate, and a sales. And then we're going to keep this problem solving one. It says solve problems involving simple interest. We're going to keep that one for day 2. So there's still a whole lot on day 1 for us to do. Actually, tip and commission are day 2 as well. So we're just going to be focusing on this first objective today. All right, so first of all, indicate the financial topic discussed in each verse. So if you can, we'll pause and look at these together in class when I come back on Wednesday. Okay, we'll look at those together. So we're going to skip on down to the next part. Percent equation, right? We've been working with this percent equation. It has frequent financial applications. Okay, remember that percent equation is the percent times the whole equals the part. Okay, you're going to need to remember that. But we're going to tweak it a little bit today. So an understanding of the proper use of money is important to live a godly life. That's what all these scriptures kind of lead back to, is like the importance of using money wisely and using it properly to live a godly life. All right, but again, we'll look at those scriptures on Wednesday. Okay, so let's move on up here to look at some vocabulary we're going to need. Percentages are often used to determine retail and sale prices. So there's a whole lot of definitions here we need today. First is the cost of something. That's the amount a merchant pays for the merchandise he will sell. The markup. So this is the amount the merchant adds to his cost. So he's adding it to his cost to arrive at the retail price. Okay, so something, the price that you pay for something. Now, there's an asterisk here because markup is necessary so merchants can cover costs and make a profit. Otherwise, their business isn't worthwhile if you're not making a profit. We've kind of talked about that a little bit when we talked previously about maybe mowing lawns and things. You have to make a profit on your job. Okay, so we have a markup rate. Okay, notice there's markup and markup rate. The rate is the amount of markup on an item as a percent of its cost. Okay, so anytime we see rate, we need to know that rate is a percent. Then we have the retail price. So this is the merchant's cost plus the markup. So they talked about retail price up here. Now we're just defining it again specifically. So it's the merchant's cost plus the markup. Okay, it's the regular amount a merchant asks the customers to pay for each product, right? If you go to Walmart and you buy a 20-ounce bottle of soda at the checkout, it's like, I don't know what, $2.15 now or something. Okay, that's the price of it unless it's on sale, and then we get a discount. Okay, so then we have discount rate. This is the percent again by which the retail price is reduced. So our rate is our percent. The discount is the amount by which the retail price is reduced. So this is, the discount is in actual dollars or cents, okay? And the sale price. So the sale price is the customer's cost after the retail price has been discounted. So that's after the sale, after the discount. Okay, some formulas that you need to know. We have the markup equals the markup rate times the cost. So the equations that you need, okay, we have markup, so the markup amount equals the markup rate. Remember that rate is the percent times the cost. Okay, this is the same. We're just taking that percent equation and we're manipulating it. Remember, for the percent equation, we had the percent times the whole. Okay, well here we're taking the markup rate, which is the percent. We're multiplying it by the whole, which is the cost, and it's getting us the part that is the markup. Okay, so we're still using that percent equation. We're just renaming the parts of it to make it a little easier to think about. And then to get our retail price, we're going to take the cost and add the markup to it, and that equals the retail price. Or if we're looking at a discount item, okay, we're going to take that, the discount is going to equal our discount rate, which again is our percent, times the retail price. That's the whole price of the item, and it's going to equal the part that we're going to discount. Okay, so it's the same thing, we're just tweaking it to rename the parts for us to use. Then if we take the retail price, so the price of the item, we subtract the discount, so the amount that we get to take off, we get our sale price. Okay, so again, we're still working with this percent equation, we're just manipulating it a little bit differently. Okay, but each of these, hopefully you also see that in each of these, it's kind of a two-step process, right? We have the one step is to find our markup, and then our second step is to find the retail price. Or if we have a discount, the first step is to find the discount amount, and the second step is to find the sale price. All right, so let's look at example 1. Tom and Harry Sporting Goods marks up all clothing, so check that out, marks up all clothing 75%, so this is a rate. If their cost for a shirt, so here we have cost, is $15, what retail price will Rich have to pay? All right, so we're looking, I've got it broken down for us, giving you the formulas that you need to use to start off, okay, really kind of guiding you through to help with this. So to find our markup, all right, our markup is going to equal our markup rate, which is 75%, so we're going to have 0.75 times the cost. The cost of the shirt is $15. Okay, so 0.75 times 15. Get out your calculators, right? We've been working on you using them. So what is our markup? Okay, hopefully you have it by now, that it's 11.25. Okay, is our markup. That would be $11.25. Okay, now then, we want to find the retail price. So we're going to take our cost. The cost is $15. We're going to add the markup amount, which is here, $11.25, and that's going to equal our retail price. So what's 15 plus 11.25? Good. 26.25 equals our retail price. Remember, this is in dollars. That's our final answer. So you should put the dollar sign on it. So if Tom and Harry Sporting Goods buys a shirt for $15, they're going to sell it for $26.25. Okay, that is, they have to add that $11.25 for their markup. Okay. Let's flip over and look at the back side. All right, example 2 says determine the retail price. So we're going for retail price of a tennis racket if Paulo saved. Ooh, he saved. So we're looking for discount. Okay, that's why I've chosen discount over here. So he saved $52.50 by buying it during the 30% off sale. How much did he pay for the racket on sale? Okay, so we have to determine the retail price if Paulo saved $52.50 by buying it during the 30% off sale, and how much did he pay for the racket on sale. All right, so we're doing two different things here. All right, so this time we're using a discount because we know that he saved money, so we're looking at the discount items or ideas. Okay. And then we need to think about, okay, well, how do these pieces fit into this equation? So do we know the discount amount? Well, yeah, we do actually. That's the $52.50. Then we have equals. Do we know the discount rate? Yeah, it's 30%, so 0.3. Do we know the retail price? Nope, Nope, we don't. So this is going to be R times R for retail. Then we're ready to balance this equation. Okay, so to balance, we would divide by 0.3 on both sides. That would cancel. So what's 52.5 divided by 0.3? Remember, you have to put in the top number in your calculator first. So 52.5 divided by 0.3. What does that get me? All right, so hopefully you got 175 equals R. Seems like a lot, doesn't it? Yeah, but remember, this is the retail price. $175 is the retail price. And he saved $52.50. He didn't pay that. That's what he saved. So now we need to find, right, how much did he pay for the racket on sale? So we know the retail price. We just solved for that. So we're going to put that in this equation. It's 175 minus the discount amount. Well, we know his discount was $52.50. And that's going to equal our sale price. All right, so what's 175 minus the 52.50? Okay, it's 122.5. We're talking about money, so you need the 0 and you need a dollar sign. It's $122.50. Okay, it's how much he paid for the racket. And that was 30% off. Okay, the 30% off sale. Good. So obviously on your homework, you're going to have to pick which two equations to use, but you're going to do that by determining if you're working with a discount or a markup, okay? And then use the two equations or the two formulas that go with those. Example 3, determine the retail price. So we're going to have to find this retail price of a pair of running shoes and the discount, okay? If they are 40% off and have a sale price of $54. Okay, so we've got our two formulas for discount. All right, determine the retail price of a pair of running shoes and the discount if they are 40% off and have a sale price of $54. Okay, so do we know the discount? We do not know the discount amount this time. Do we know the discount rate? Yes, right? That's the 40% here. Good. So this is going to be 0.4. Do we know the retail price? No, we don't. So right now we're looking at 0.4 R equals D, the discount. What do we think about that? Right? We don't know the discount amount. So, Okay, so do we have any thoughts on this? Okay, you can also think about a couple days ago, we did some of these in class. We did one example when you guys had a question. We can't solve when we have two variables. So sometimes we have to change the way we're thinking about this. Okay, our discount equals the discount rate times the retail price. Okay, that's what we've been doing, and that's true. But in this case, when we have two variables and we can't solve, we might have to change the way we think about it and say, well, our sale price, instead of thinking of our discount, think of the sale price. That would equal not the discount rate, but the opposite of the discount rate, like the complement of that. So we'll call it the complement of the discount rate times the retail price. right? So the price that we're going to pay, because when we do the discount, right, we find the discounted rate from the retail price to get our discount, and then we subtract it. We can also think about the inverse of that, okay, which is the sale price, how much we actually pay, and the complement of the discount. So what's the other part? If we're saving 40% or getting 40% off, what percent is he paying? Okay, great. That would be 60%. Okay, so this is 60%. The sale price we know is $54. So 54 equals 60% times the retail. Now we only have one unknown, so we could solve this. So 54 equals 0.6 as a decimal, R times the retail. So if we divide by 0.6, what is 54 divided by 0.6? I hope everyone has their calculators today. All right, hopefully you got 90 equals R, the retail price. Now you could even check that, right? You could put this back into here and see, well, the R would go over here. What is 0.4 times 90? Okay, so check that. Okay, that gets you 36. So now you know your discount, right? You could plug that back in and you get your discount of 36. Or you could come over here and do this equation. Your retail price, which we just found was 90, minus your discount equals the sale price. The sale price was 54. Okay, so this is another way to find your discount or to check it to make sure you did everything right. So we would subtract 90 from both sides. 90 minus 90 is 0. We have a negative, right, D. So negative D equals negative 54 minus 90 gives me a negative 36. Okay, I'm going to have to divide by -1 to get rid of that negative. So then we have the discount equals $36, which is the same thing you got if you would have plugged 90 back into this equation. Okay, so sometimes you don't have to use all of every equation. That's kind of nice. All right, the star here, the asterisk, said you could also use the percent equation. Percent times whole equals part. Okay, that's what I talked about at the beginning. You can use that percent equation because it's the same as the percent times your retail equals the sale price. We're just manipulating those a little bit to make it apply to what we're doing. All right, that is it. Good luck on your homework, and I will see you tomorrow.